There are a number of ways to make a power sensor for your laser. What I've got here is a simple Peltier Junction. So if I put voltage in on the red positive and black negative, it will get very cold here and heatsink will warm up. It'll be a heat pump. Now these work in reverse. So if I reverse my leads, I've got black on the red wire and red on the black wire, and I add heat by putting my hand on here. You'll see the voltage jump up. And if I take my hand off, of course the voltage will go back down. So if we want to make a laser power meter, we need to paint this black so that it absorbs as much as possible, and we need to calibrate it. And to calibrate it, we can simply put some resistive wire, even this copper wire will work, on the front of this Peltier junction here. Just glue it in place, and then when we put a current through that, we're applying a known amount of heat to it, so we can figure out how strong the laser power was based on how much power we put in to the heater versus how much power we put in from the laser, and try to match those numbers on the meter. So let's try to make one of these. Now it's kind of embarrassingly messy here, all those little crisscross windings, but it's the best I can do by hand. I guess machines would make it easier. This is some silver glue paste, so I'm going to try to silver paste this stuff down so that we have good thermal contact, and of course we'll have to thermal paste the whole thing, so it's going to take a while for that glue to dry. We're going to want to make it nice and flat, so we're going to have to do some tricks here. Just kind of tack these down to get started. Alright, so here is the Peltier junction with the thinner wire on it glued down with silver paint for good thermal conductivity, and then we're going to spray paint it black. Okay, we just spray painted the sensor here with chalkboard paint. It's nice dark, flat dark black. It's got extra ceramic material in it so that it's hard, and I think that'll help keep it from burning. So just taking the mask off here. There we go. Okay, here's the Peltier junction with the resistance wire set up on the front of it. The wires go up to power supply, which is at 1.5 volts and 2 amps. So that's putting 3 watts of power onto the front of the Peltier junction, and I'm reading the voltage on here, 0.43 volts. Now we want to put the laser on it and see if we get about the same number. Okay, I've got the laser module itself removed from the laser, and I have it hooked up to a power supply, so I know how much power is going into the module. Right now it's set for 8.4 volts at a max of 1.5 amps, but I think it will max out the current here. Yeah, almost 1.4 amps it looks like, and about 8 volts. And my Peltier junction here is rapidly rising, and I can also feel the heat in the laser module going up pretty quick, which is a little scary. Looks like I'm getting about 0.16 volts here across the Peltier junction, and this is probably hotter than it normally runs in the module, in the laser pointer itself. Give that a minute to cool down, and then we'll try to match that number with the power supply through the resistive heater on the front there, see if we can get an accurate number. Okay, here we go. I'm going to turn on the power supply now, and it's running power through this heater on the front, and we're going to see if we can get about 0.16 for the heater power here. Looks like I'm going a little over here. It's in the ballpark, it's about right. So that's showing about 1.3 amps at almost a volt. I'll have to check the voltage here and do a quick calculation. 1.3 amps times a volt is 1.3 watts. So where's the rest going? Reflection? I hooked up a 7-watt diode from DTR's laser shop, which he provided a power measurement with, and I had the laser voltage and current. So I knew how much power was going into the diode, and I knew how much power he was measuring. So I was fairly certain I was able to calibrate my junction. And using this calibration, I came up with about a 60% absorption factor, and I concluded that the Lark 3-watt laser is putting out about 2 to 2.5 watts using the batteries supplied, which are definitely weaker than my power supply. Even if it's only 2 watts, it's still fun to burn wood from a couple feet away.